Good morning, good afternoon, good evening, wherever you're watching me from. This is Osmart Tutor, where chemistry is made easy for every learner. Today we are exploring the carboxylic acid, and I want you to get your pen and paper and get set your table as we move on in the study of carboxylic acid today. Please don't forget to like, share, and comment on the video at the comment section. I will really appreciate your comment for a better video. Thank you very much. So, like I said, we're looking at carboxylic acid. The carboxylic acid, they are also known as arachidonic acid. The arachidonic acid is the old name used, to represent this carboxylic acid. However, whether old or new, the carboxylic acid or arachidonic acid, they are the same homologous series. So don't let the name confuse you whenever you heard about carboxylic acid or arachidonic acid. So what are carboxylic acid? Carboxylic acid, they form a homologous series, just like every other family of the organic chemistry. They have the general formula CN H2N plus 1 COOH. This is the general formula. The general formula. So don't forget, whenever you are to write any formula of the carboxylic acid, you can make use of this general formula. So let's start preparation of a carboxylic acid preparation. Carboxylic acid being an organic acid is different from our inorganic acid. So we can prepare carboxylic acid, from two ways, which I will discuss this morning. The second one will briefly touch it. I will just talk about it briefly. Or the second one will really delve into it. Now, the first one is from bacterial action. When carboxylic acid, when alcohol are being acted upon, using a catalyst, you can produce what? Carboxylic acid. That is one. Then secondly, by bacterial action. So for this morning, I'm going to start. I will use two methods to prepare carboxylic acid. Now the one from the alkanols. First of all, you must understand what alkanols are. Briefly, I will just give you a brief introduction to alkanols. Alkanols, they are also known as alcohols. They also form homologous series with their functional group, hydroxyl group OH. So for the alkanols, they have the OH as the basic functional group. So why are we talking about alkanols when we are preparing carboxylic acid? This is because we can produce carboxylic acid from the primary alkanols. Then what are primary alkanols? Primary alkanols, they are the alkanols that have just one alkyl group attached to the carbon carrying the functional group. And this carbon carrying the functional group is going to carry two hydrogen atoms. That helps you to easily identify what primary alkanols are. Two hydrogen atoms attached to the carbon carrying the functional group with the OH, which is the functional group. Don't forget. So for that, I would like to give this example. Let's say you have your ethanol. It's a common example. The ethanol is a common example of the alcohol. Our ethanol has the formula CH3CH2OH. Expanding this, I can have 1, 2, 3, 4. That's 1. 5 hydrogens. Then you have the oxygen and you have the hydrogen. This is your alcohol, a primary alcohol. This is ethanol. Now, this ethanol can be used to produce carboxylic acid. Now, bear in mind, we're having two carbon atoms here. So that means we can only produce the corresponding acid from this ethanol. So if I'm using ethanol, I will produce ethanoic acid. Okay, so now let's go. What are the catalysts used in this process? The catalysts used in this process, there are two, basically two. One is mild, one is very, very strong. The first one is potassium ether, also dichromate 6, with the formula K2Cl2O7. That one will give us an intermediate. So let me use that one first. So I have K2Cr2O7. Then I put my O indicating what? Indicating oxidation. So this catalyst is a mild oxidizing agent. It's going to oxidize this ethanol to ethanol and aldehyde, which is an intermediate. So what is the intermediate? I'm going to have what? CH. Okay, so this is our intermediate. Now, to avoid confusion, I'll just continue on the straight line so you can get this particular equation. Now, I'll still use the same catalyst again, the same catalyst, which is a potassium ether oxo dichromate 6 again, then to get to where we are going. This second oxidation now will give us our desirable result, which is the ethanoic acid. Ethanoic acid. So this is our ethanoic acid. From ethanol to ethanol and ethanoic acid. This is the ethanol, a primary alcohol with only one alkyl group. I will use R to represent my alkyl group. So then here is what? Ethanol. This is aldehyde. Aldehyde. And here is the ethanoic acid. A carboxylic acid. It's also called alkanoic carboxylic acid. That's ethanoic acid. So this is one of the methods of preparing carboxylic acid from ethanol. From ethanol, you may be asked that, let's say you are asked a particular question that a particular acid was prepared from such and such, and name the catalyst used, name the intermediate. You should know that the intermediate form in this process is the ethanol, which is the aldehyde, and the real product is what is ethanoic acid. So that is the first step. Now the second step, I'm going to use the second oxidizing agent. This oxidizing agent is very, very strong, and I believe you are familiar with it. And if you are not, the name is potassium tetraoxomanganate 7. Potassium tetraoxomanganate 7 with the formula KMNO4. KMNO4. So this particular oxidation will not stop at anywhere but go straight to the final destination. So there is no intermediate form because this is a very strong oxidizing agent. So here we go. Still from the same primary ethanol, I'm using ethanol C. So I'm using KMNO4 now, like I said. In this case, the product form, it is directly ethanoic acid. Ethanoic acid. So this is the second method by using strong oxidizing agent KMnO4. So this is just a brief introduction on the preparation of a carboxylic acid. I hope we got this particular method clear. Okay, now we move on to the next step. So I'm going to clear this one off now. I'll move to the next stage. Okay, okay, here we go. All right, welcome back. The next step is the properties of carboxylic acid. Just like every other acid, carboxylic acid behaves like our normal inorganic acid because it is an acid. And by definition, an acid is a substance, that donates a proton. So an acid is a proton donor. An acid also turns blue litmus paper red. So an acid has sour taste, but I'm not saying if you go and taste any acid, please. We can only use fruit to test all those properties. So here now we are looking at the chemical properties of carboxylic acid. So as an acid, it will react with metals, and let's see the result. So with metals, let's say e.g. Let's take the one or two metals for instance. Let's say sodium, and the formula is there, the symbol is Na. So if you react sodium with ethanol acid, you are going to have a product. Okay, now here we go. This is your ethanol acid, and this is the metal sodium. We are using sodium as our example. Now, when metals react with acid, you should get this one very, very well, that hydrogen gas will be produced automatically if it is an acid and it's reacting with a metal. Now, but mind you, only metals that are above hydrogen in the electrochemical series, the one you call activity series. Okay, so only those metals can displace hydrogen from acid. Okay, so here we go. You have sodium here, and so this hydrogen will be removed, will be replaced by sodium, and that is the only replaceable hydrogen ion there. So the sodium moves in here, then hydrogen gas goes out. So you have so now we are having what hydrogen gas as a product being given up. How do you know that this test is positive? You can always test whether it is positive or not when you introduce a light splinter into this particular gas given off, and then you have a pure sand being produced. Is that clear? Okay, I think let's have a demonstration of that. Okay, let's have that one demonstrated now. Like I said, as an acid, it reacts with metal to produce what? Hydrogen gas. Here is our ethanoic acid, that's acetic acid, and here is a sodium metal, and here is a piece of sodium metal and a petri dish here. Okay, so we demonstrate that now. So let's see if it's going to actually produce hydrogen gas or not. Okay, for the sake of this class, I'm using my a piece of sodium metal here, acetic acid, which is ethanoic acid, and I'm using the matches as my light splitter this morning. This is a spatula. This is ethanoic acid in a reagent bottle, and here is my body. I'm using it to demonstrate that practical this morning. So let's have our metal in the boiling tube. I will add gently add the acid. I'm going to repeat that experiment now. Sodium metal is very, very reactive, so I'm going to take a very small piece of it this time around to avoid any explosive action. So here we go. As you can see, the reaction is going on. And how do we confirm that? Sorry, just a moment. So that the gas will not escape. That's why I have to block the mouth or the body. Here we go. That shows that hydrogen gas is produced from the reaction of ethanoic acid with sodium. It's a metal in the group 1 series of the activities series. The next reaction of carboxylic acid, we are going to see the reaction of the acid as it reacts with carbonate. So this is like a neutralization reaction properly. A neutralization reaction. So the second one is with carbonate. With carbonate. Carbonate, we have the CO3 minus there as the major radical there. And so, let me just give you this particular dummy so you just recall. Whenever acid reacts with carbonate, we are going to have a salt, water, and carbon 4 oxide, or otherwise called carbon dioxide. So why am I using these two names? The British, the Cambridge NZ, they recognize this one, while the West African they use this one majorly. So carbon dioxide is our UPAC nomenclature for West Africa and some other country, while the British Cambridge they make use of the carbon dioxide, which is the old name. All right. Now we also need to demonstrate this to see the reaction of carboxylic acid or the reaction of ethanoic acid with carbonate. So this morning I'm going to use calcium carbonate powder, with my ethanoic acid. So here we go. Let's quickly demonstrate that. Here is a powder calcium carbonate in a boiling tube here, and I still have my favorite acetic acid here with me. So as we demonstrate this, we are going to see a colorless gas giving off. This gas is calcium, that's carbon dioxide. And how do you test this gas? Although we will not test it this morning because of a time frame. So you can test this gas that will be sure that this is the gas given off when you introduce the gas to lime water, which is also known as calcium hydroxide. So here we go. Wow. You can see this. You can see the physics coming out. Now, it is more vigorous than this, but because ethanoic acid is a weak acid, but you can still see the reaction coming out now, reacting now. That is carbon dioxide giving up, carbon dioxide being given up. So that is the second reaction. Okay, let me put it there so that we can continue with the lesson. That's good. That's good. The next reaction. So let me write the equation for the reaction first of all before we close this chapter. So I have C this calcium triisocarbonate 4, also called calcium carbonate. Okay, calcium triisocarbonate 4. So with this we have calcium is going to replace the hydrogen here, and the hydrogen is going to combine with this, while calcium replace the hydrogen here. So we have calcium having a valency of 2 is going to be Cl CH3 COO bracket 2 plus H2O plus CO2 gas, liquid and gas. So this compound form now is a salt and it's an ester. So this is calcium ethanoate. Calcium ethanoate. So this is salt, which is different from our normal regular salt. But like I said, the major product of this reaction are salt, water, and carbon dioxide. So that is the second reaction of ethanoic acid, one with metal, two with a carbonate. So let's now see the third reaction of carboxylic acid with base in transition reaction. Although these reactions are almost similar because we have salt here, we have water, and we have carbon dioxide here. But let's go with the third one now with alkali. With alkali. So it can react with any of the alkali as well, giving us salt and water only as the normal neutralization reaction. Okay. The neutralization reaction is the reaction between acid and base or alkali to produce salt and water only. Salt and water only. Okay, here we go. Now what's going to happen here? This H is going to combine with OH there, then sodium come and take the place of hydrogen here. So we have so the products are salt and water only. This is the salt and this is the water. This is sodium ethanoate. Sodium ethanoate. This is an ester as well. So this sodium ethanoate is salt, and here is the water. So this morning we've explored the preparation of carboxylic acid from ethanol. Then we look at the properties of ethanoic acid as it reacts with metal like sodium, a group 1 element, as it reacts with carbonate, calcium carbonate, as an example. And number 3, as it reacts with alkali such as sodium hydroxide to give us salt and water. To give us salt and water. So thank you very much for watching this morning. If you have any question, please do comment on the comment section. Don't forget to share the video. Also ask questions. I will be waiting to respond to your question appropriately. And I will appreciate your feedback on this particular lesson this morning. Thank you very much.